Up next on the workbench, I'm going to show you all the steps I followed to interface this chip with an Arduino board and use it exactly like a standard SD card. Let's get started. Hey everyone, Chris here. Today we're working with this XTX chip. Compared to a traditional SD card, this chip has a smaller size footprint and offers a significant advantages. It can be soldered directly to a circuit board while functioning identically to an SD card. The chip even maintains the same SD card pinout, which we will take into consideration when wiring it to an Arduino. To access the chip's functionality, I designed this custom breakout board to easily interface with all its pins. I moved to Altium Develop to create this straightforward schematic where I duplicated the XTSD chip for both the top and bottom assembly and connected its pins to CL connectors. I then transformed it into a PCB design, placing the chip at the center of the top and bottom layers and positioning the CL connectors along the sides of the board. I carefully followed the standard SD card layout to create the PCB edge connection. Here is a 3D view of the final PCB design. You can access the design files on your own device using Altium Develop online accessibility features. Just click the link in this video's description to request access to the project and I will approve it. Once approved, you will be able to examine all project display formats like Schematic, PCB View, and 3D Render. You can also leave comments or questions if you need any clarifications, and I will interact with it from my designing interface by giving you direct replies. This tool is incredibly valuable, especially for team collaboration, as it provides you instant access to project files wherever you are. Back to our circuit, I labeled the chip's pinout to guide the wiring to the Arduino. The next step was ordering the PCB. I moved to JLCPCB where I uploaded the Gerber files, which you can get for free using the download link in the video description. I selected a blue solder mask color and gold nickel surface finish. The most important parameter is the PCB thickness. If you plan to use this PCB with a standard SD card readers, the thickness must not exceed 0.8 mm. I set it to 0.6 mm and placed my order. A few days later, I received this iconic blue box from JLCPCB containing the perfectly produced PCBs. Now with the chip, PCB and CL connectors ready, it was time for assembly. I applied solder paste to all the chip pads, carefully placed the chip, and used my hot plate to complete the soldering. Here is a microscopic view of the assembly. Next, I soldered the CL connectors using a soldering iron and copper core solder, ensuring they were aligned with a breadboard array. And here is our finished circuit. The first test was to see how my computer would recognize the chip. I inserted the circuit into a standard SD card reader and plugged it onto my computer. And it worked. The chip was detected as a normal SD card with no drivers or extra software needed. I created an Excel sheet on it, copied a PNG image, and then safely ejected it to proceed with the wiring to the Arduino. We're interfacing with this chip through the SPI port, so we need to follow this wiring diagram with the Arduino. I used my breadboard to establish the SPI connection, then ran a quick sketch from the Arduino SDFAT library. After uploading the code, I opened the serial monitor, and guess what? The Arduino successfully accessed the chip and everything works perfectly. I designed this code to create a user-friendly interface with all these features. Before testing them, I disconnected the power line and rebooted the Arduino. The system detected the malfunctioning, and after 3 automatic reconnect attempts, the code recommended debugging steps. I plugged the power back in and clicked to reconnect. Connection restored. Now I selected List All Files and the Excel sheet and PNG image appeared. I created a new file to test access. It showed up immediately. We can write a sentence to this new file and the Arduino automatically saves it. We can also read the file content by specifying the file name. Here is the sentence, we save it. We can check SD card info and explore other features as well. I reconnected the SD chip to my computer and you can see the text file we created, already containing the stored data. I copied the G-code from an STL design to the SD chip and plugged it onto my 3D printer to print this 3D designed SD card modeling. The chip worked flawlessly with the 3D printer as well. This is an extremely useful solution where space is critical in PCB designs. That's all for today. Share your thoughts in the comments. One last thing, make sure you are doing electronics every day. It was Chris. See you next time.